All right, so today we're going to do a conditional statement. So mathematics is more than just counting things and using numbers. We have to logically prove how those numbers exist and how we add numbers and how we subtract numbers. And with regards to geometry, we define what a triangle is, we define what a line is, we define everything in geometry on 4 basic principles that we can't prove to be untrue, but we assume that they're true, and everything is structured on that. So everything in geometry, triangles, shapes, planes, lines, rays, all of those things are used to build what we would call a logical proof. And because they're proven to be true, there's a consistency. 2 plus 2 will always be 4 because it's built on logic. It won't be anything else because of the way the system is set up. If I take 3 sides and I connect them in a certain way, it makes a triangle every time in a 2-dimensional plane in Euclidean geometry. Euclid was the guy that kind of gets credit for writing the first geometry book. It was a long time ago. But all the stuff that he did was based on logic. And one way that we can prove things is called a conditional statement. And so a conditional statement is if something, 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 then something must be true. So you see those bumper stickers on the back of cars? If you can read this, comma, then you're too close.
That's a condition.
Right? That's a conditional statement. What it's saying is if you can read this, which is true, then you're too close, which is true. And that's what we're going to talk about today. So before we jump into that, I'm gonna write down some things that you'll need to know. So a conditional statement, and whatever I write down, you should write down today, because I'm going to go kind of fast. Really, it's just an if-then. We call it an if-then statement. If something happens, then this is true. And normally, the symbols that we use, we would say if P, then Q. Okay? If P, then Q. And then sometimes we could use like a diagram. We could do something like this where we say, sometimes we'll do something like this. So if P is true, then Q is true. So we have a symbol and the definition and the diagram. And so of this, we have a couple different parts. P is always going to be what we call the hypothesis. Hypothesis. I always do that. And that's P is always referring to the statement if. That's the P part. So P is the statement, right? So for example, P could be if you can read this. Okay? Then the other part is what we would call the logical conclusion. So the conclusion follows the cue. So that would be like, if you can read this, then you are too close. Does that make sense?
Yep.
So now whenever we see this PQ, we can think of this 2 different ways. So you guys got this all jotted down? Can I move on to the next slide? Yeah. Yeah? Yes? No?
Yeah.
You guys are welcome to slide your desk over a little bit to help you. I kind of need the podium here so I can hold my book. Okay. So now what I want to write down, and I got to go to the next slide before I don't know. Okay. So let's unpack that a little bit. If I say P Q, if you see this, you should think to yourself, if P, then Q. Or P implies Q. That's two ways you could write it. Okay? So let's do example number 1. Are you guys ready?
Yes.
So now for example number 1, we have the hypothesis and the animal, whoops, is a robin. That's just a statement, all right? So P and Q are always statements. And then for Q, our conclusion, the animal is a bird. Now, how would you write that as a conditional statement? How would I say P implies Q? Yes?
If the animal is a robin, it's a bird.
Yeah, if an animal is a robin, it is a bird. Very good. So if an animal, why do I keep putting the M first? Then it is a bird. I should point out that this is a conditional statement that is only what we call a unidirectional statement. It doesn't go backwards, all right? P implies Q. Q cannot imply P. That would be a biconditional statement. That's something different. In other words, if it's a bird, doesn't necessarily mean it's a robin. Does that make sense to you guys?
Yeah.
So the way that this is set up, P implies Q. And the only validity I could get out of that statement is if the first part is true. In this particular case, right? The way that I've got, we'll teach you other ways, but for right now, focus on that. If an animal is a robin, then it is a bird. We're not talking about if it's a bird, then it's a robin. That's something different.
What's that called again?
No, this is just called a conditional statement.
No,
So
the
we're just
opposite
doing conditional statements.
Wait,
The
is
opposite
it
one,
like
what's it called?
Was it like?
Oh, a biconditional statement would be Q can imply P and P can imply Q. In this particular case, because the arrow is only going one way, that means that only P can imply Q.
What is that called?
Conditional statement.
Like you said, like uni something.
Well, it's unidirectional. It only goes one way.
Okay.
Only P can imply Q. Does that make sense? All right. So that's a conditional statement. In other words, based on the condition of the first statement, that determines the validity of the second statement. Right? We don't gain anything unless that first part is true. When you think about it, at least at this stage, there'll be times where we'll change this up and do things a little differently, and then we could get some information out of it. But right now, if it isn't an animal, if it isn't a robin, if the animal isn't a robin, we know nothing. So if I say if an animal is a robin, then it is a bird. Well, what if it's a chicken? Do I know it's a bird? Not based on this statement. Well, what if it's a tiger? Is it a bird? Not based on... The only thing that I can imply is that if it is a robin, then it is a bird. Based on this structure, the way that I've set it up. Does that make sense?
Yes.
All right, so let's move on to example number 2.